Hello. In this video we're going to look at some applications of derivatives. So if we have a demand function that gives us how many items, Q items, that we will sell at a price of P dollars, given by Q equals 4,000 minus 100P. Part A the first part wants us to find our revenue function R of Q. Now remember, revenue is equal to price times quantity. So we do have a function for quantity, but we want our revenue to be in terms of the quantity. So we need to make sure that we are plugging in our price in terms of quantity. So for this problem, we do need to solve this for our price so that we can plug in. So if we solve this for price, let's see, we'll subtract 4,000 and we'll divide by negative 100. So Q divided by negative 100 will be negative 1 over 100Q. Negative 4,000 divided by negative 100. Negative divided by negative is going to give us a positive. And then 4,000 divided by 100 is 40. Gives us our P. So we're only having to solve for this because we don't know what our price is in terms of our quantity. So now let's plug in. So the revenue in terms of quantity is going to be our price function, which we just found, negative 1 over 100 times Q plus 40 times our quantity. And if we wanted to distribute that Q, make it a little bit easier for our next step, distributing that Q, we'll get negative 1 over 100Q squared plus 40Q. So there's our revenue function in terms of our quantity. Now the next part wants us to find the marginal revenue. Now marginal revenue, we always are going to take the derivative with respect to our quantity. Can't find the marginal revenue if we don't have our revenue function in terms of our quantity. So if we take this derivative with respect to Q, R prime of Q is going to be negative 1 over 100 times the derivative of Q squared, which is 2Q. So that'll be negative 1 over 50 times Q. And then the derivative of 40Q is going to be 40 times the derivative of Q, which is 1. So that is our marginal revenue function. And then the next part wants us to find and interpret R prime of 1,000. So R prime of 1,000 means that we're going to plug in 1,000 into our function, negative 1 over 50 times 1,000 plus 40 gives us 20. Now the units on this, because we are taking our derivative here with respect to quantity, that means our revenue price was in dollars, so revenue is in dollars. So the units on our marginal revenue are going to be dollars, and then the units on our quantity are going to be items. So the units on our marginal revenue are dollars per item. That helps us out a little bit to interpret this. What this is telling us is, at least while we're at pretty close to $1,000 or 1,000 item output, our revenue is going to be about $20 per item. All right, let's look at another example. In this example, we have a population function, P of t equals negative 0.26 t cubed plus 1.25 t squared plus 249.3 gives us the population of a community in thousands t years after 2000, after the year 2000. So the first thing we need to do is find what is the rate of change of the population in 2005. In order to do that, we need to find our derivative of our population function. So negative 0.026 t cubed, the derivative of that is going to be 0.026 times 3, so negative 0.078 t squared plus 1.25 t squared. The derivative of that is going to be 2.5 t to the first, and then 249.3 is a constant, so our derivative is 0. So if we want to find the rate of change of the population in the year 2005, we are going to plug t is years after 2000, so that means t is 5 here. So if we plug in a 5 into that, we should get 10.55. Now the units on this, remember, population is in thousands, and we're taking the derivative with respect to time, and so that means thousands per year. So in the year 2005, our population was growing at a rate of 10,000 people per year for this community. In the year 2010, we're going to be doing the exact same thing we just did, but we're going to plug in t equal 10. And so if we plug in t equal 10, we're plugging it into this function right here. We should get 17.2. Again, our units there are thousands per year. And then at 2015, that's plugging in a t value of 15. We get 19.95 thousands per year. And then in the year 2020, according to this model, the population grew 18.8 thousands per year. So what does this tell us about the population? Well, if we go back and look at those numbers, we have in 2005 we had 10,000. In 2010 it grew at a rate of 17,000. In 2015 it grew at a rate of 19.95, almost 20,000. And in 2020 it grew at a rate of 18.8 thousand. These are all positive numbers. That means that it's all, during each of these years, our population was growing. It was getting larger. Now, on this last one, it does go down. That just means that it's growing a little bit slower, but it's still growing. And so what does this tell us about the population? Since all these values are positive, the population is growing from the year at least 2005 to 2020. Beyond that, we don't know. If we had gotten any negative numbers, that would mean that it was going down at that point. And but since all of these numbers are positive, that means it is increasing the entire time. All right, I'll see you guys next time.